This microcredential deals with virtualized systems consisting of 4 targeted skills. This targeted skill deals with system requirements. The first requirement for virtualization is that the central processing unit or CPU, the motherboard, and the BIOS or UEFI of the computer include hardware virtualization support. Almost all modern computer components support virtualization. If in doubt, a user can look for Virtual Technology Computer Support (VTX) for Intel processors and AMD-V for AMD processors. Even if virtualization is supported, a user may still need to enable it in the BIOS or UEFI. Random access memory, RAM, is the most critical concern for virtualization. It is the workspace of any computer. Software such as the operating system, OS, or applications are stored on the hard drive. When the computer boots or an application is opened, it runs from RAM. Each running VM is allotted a portion of the physical memory. So a host machine must have enough memory available to support the host OS as well as each running VM. Storage is another concern. Each VM file contains not only the OS but everything installed on the VM. Depending on how the VM is used, these files can be quite large. In addition, every backup and snapshot requires space as well. If performance is an issue, the user should consider using a solid-state drive, SSD, instead of a traditional hard drive. VMs represent an investment of effort and time and can mean downtime if lost. To prevent this, a consideration should be given to protection with regular backups or a redundant array of inexpensive disks, RAID array. The guest machines need some way to connect to the network. The host machine should have at least one network interface card that the hypervisor can use to provide this network access. Virtual machines can be configured with host only, network address translation, or bridged network access. Host-only configurations only allow the host and guest machines to communicate and provide no network access to the guest. A configuration like this could be used to sandbox guest machines and provide the highest level of security. In a NAT configuration, the guest machines are assigned IP addresses by a Virtual Dynamic Host Configuration Protocol server and are on the virtual network separated from the host local area network. The guest machines are hidden behind the IP address of the host and don't appear on the host network. The host and guest VMs can communicate with each other, and the host acts like a router providing internet connectivity. However, traffic from the guest machine to other devices on the host local area network is blocked. A bridged configuration is the most common type of configuration. In a bridge configuration, the host machine shares the NIC with the guest machine, which receives an IP address and connects to the same network the host machine connects to. If the VMs are going to be servers, the traffic that they generate may be too much for a single NIC. In this case, the host machine should have multiple NICs using bridging dedicated to each VM. Basic system requirements for a virtualized system were discussed in this targeted skill.